the correlation between structure, properties, processing, and performance is simplified as a material tetrahedron model. Why we call it tetrahedron is because of the shape of this model. We have done with what is structure and what is processing, as well as how it correlates. Now we move to properties. So property is material trait or material characteristic or quality of material in terms of response to a specific environment and external forces. There are several types of properties. One is mechanical properties, when the material responds to mechanical forces or stresses. It will determine the strength of the material. Second is electrical and magnetic properties, where the material responds to electrical and magnetic field, whether it is conductive or insulator. Third is thermal properties, when material is related to transmission of heat and heat capacity. It can be thermally conductive or thermally insulative. Fourth, optical properties, the response of material to light or electromagnetic radiation. It includes absorption, transmission, and scattering of light. By using these optical properties, you can create something such as microscope, as well as you can magnify something using lenses. And fifth is deteriorative, indicating the chemical reactivity of materials, how the material resistance towards the chemical attack. This is the example of property. This one is for the mechanical property. You see how this bend need to perform well under the stresses. Second is electrical properties. When in this electronic circuit, they are actually area of conductive and non-conductive material to be used to perform its function. Third, the optical properties, where you can have a transparent, translucent, or opaque material. Fourth, how the material behaves with heat or thermal properties. Fifth, how the magnetic properties is utilized in terms of the data storage. And fifth, how this component is experience cracking due to the chemical attack by the seawater. So, as a structure that I mentioned before, affecting the property, processing also is able to affect the property. Processing might actually increase or decrease the property of material. Say for example, there are two types of mechanical properties here. One is strength, second is ductility. Strength is how strong the material to resist deformation with the stress. Meanwhile, the ductility is the ability of the material to deform under stress. Okay, so you see, if a metal experiences annealing temperature, which is heat treatment as I mentioned to you earlier, you see, with the increment of temperature, ductility is increases, meanwhile the strength of material is decreases. Okay. However, under the cold working, without the presence of heat, the material experience reduction in ductility, meanwhile experience increment in strength. Okay. Second, effect of structure to property. You see the correlation to the electrical property. Okay. Electrical resistivity of copper. So you see this is the pure copper. You can change the structure of copper by adding nickel into the structure. You see, by adding different percentage of nickel, you see increment in terms of the resistivity of copper. Besides, with the changes in temperature, the resistivity increases. Okay, as you can see here, all the resistivity for all particular materials increases with the increase of temperature. Okay. Third, effect of structure to property for thermal. Okay. For this one, example for composite, when actually you add silica fiber for insulation. So, adding silica, which is ceramics, decreases the heat conductivity. So, it increases the insulation properties of material for space shuttle tiles. Okay, here you see the changes of thermal conductivity of copper. Copper is a type of metal which is always a conductor. Okay, however, the thermal conductivity is decreases when you add more zinc. You see, with the increment of zinc, you observe the decrement in terms of thermal conductivity of the copper material. Okay, effect through the magnetic properties, as you observe in the magnetic storage application. Okay, you know that ferrum or iron is the magnetic material. However, when adding certain percentage of silicon inside the ferrum, the material increase in the magnetization. Okay, effect to the optical property, the material interaction with light. Okay, so you see all of this is aluminum oxide. However, this aluminum oxide can become transparent, this one, translucent or opaque depending on the material structure. Okay, last but not least, on the performance. So the performance is the function of material properties which determine their one, reliability, and second is the service life. Okay, so performance means how is the material, once it's been utilized in an object, is able to sustain the function, become reliable, and at the longest life possible. So how is actually it performs their function, as well as how the service environment affecting the functions and life of the material. Functions and life. Okay. Effect of service environment and processing parameter to performance in terms of deteriorative properties. Okay, you see here for this one is the effect of service environment, where actually this metal component is experienced both stresses and chemical attack due to the salt water and causing this component to experience crack after a while. Okay, and then this one, however, is the effect studied to measure the processing parameter to the deteriorative performance. See, heat treatment slows crack speed in salt water. Okay, so you see this one is as if, means the material without heat treatment. This one is material with heat treatment. So you see the crack speed for this one as if is higher than this one, held at 160 degrees for an hour, which actually experience heat treatment while increasing the load during the testing. Okay, environmental and other effects, you see, due to the environmental factor, okay, material can experience corrosion or fatigue. Okay, metals and polymer react with oxygen or other gases, particularly at elevated temperature. So this is what happened to the metal. Okay, it become oxidized or rusted. Okay, and material also can experience fatigue, where failure or fracture had occurred to the material. Even the stresses that experienced by the material is lower than the tensile strength of that particular material. This is because this component is subjected to the cyclic loading. Next example is the effect of service temperature to performance. You can see in this graph, there are plenty of type of materials. One is polymer, metal, composite, whether it is aluminum composite, fiber reinforced composite, alloy, ceramic, and carbon-carbon composite. It shows how this material varies with the temperature in terms of its strength. So you see, with the increment of service temperature, the material experience reduction in terms of strength reduction. See? However, you see, for the carbon-carbon composite, the strength is remain even up to the temperature of 3000 degrees centigrade.